Good evening once again. I want to welcome you all to Math Invisible tutorial. And this video we continue on our topic which is logarithm. And in the previous video I've explained logarithm and some laws regarding logarithm, which are Newton's law, equal number and base, unity law, product law, and quotient law. And I solved some questions regarding all these laws. And this video, actually there's high tendency that we are still going to be making use of those previous law. That was why I said in the previous video that just apply the law where you think it is applicable. Sure, you get it now. So but in this video we'll be solving some questions regarding the sixth law, which we call change of base law. So how can we apply change of base law? So you can apply it when you have this expression like this, when you have log m base n. So in change of base law, there's one we call reciprocal law, and this one too, they are still under change of base law. Shows that you will find a constant base for the first one, that we are having log m base n equals to what? Log m base a divided by log n base a. So you will switch the log m base n by using constant base for both m and the initial base of the log. So that was why you can say in this expression that we have log m base a divided by log n base a. So another way we can express, I said earlier that you can apply this law based on your understanding of where you think the law, any law that we've been dealing with, is applicable. Sure, you get it now. So there are sometimes the application may require the second one and the first one. So you can see the second one is what 1 over. You can see that this one now, that is why we call it reciprocal law. We are switching. Sure, you get it now. The one that is serving as base now is now the number, while the one that is serving as the number is now the base. That is, log m base n can actually be equal to 1 over log n base n. So you can use these two expressions. Either you change, that is called change of base law actually. So either you change it to be what? You change the log m base n by applying the constant base for the initial number and the initial base of the log. That is log m base a divided by log n base a, or what? Or 1 over log n base n. You can see that we are switching the what? We are switching the number and the base. So let's see how we can apply this law. You can see that this particular example, especially example 1 regarding this law, you can see that all those log are having what? They are having different base. That is log 4 base 2 plus log 2 base 4 minus log 5 25 base 25 rather. So you can see that it will be difficult for us to apply what? And life, you need to make life simple for yourself. So we need to simplify it. Sure, you get it now, before we can evaluate this expression given. So how can we do this? So you think of which law can you apply, and that is why we are working on that sixth law. Because if you see question like this, it will be difficult for you to apply the product law and the quotient law. Actually, you can apply the index law, sure, but you won't be able to solve it completely. You get what I'm saying now? So with that is why you need what? You need to know this sixth law. And this expression here is what? Is log 4. Is what? Log 4 base 2 plus log 2 base 4 minus log 5 25. So how can you solve this question? So given this kind of expression, how can you solve it? So this now will take equals to what? To another line. I'm saying that what? Log. So what is the first thing we must do? You can see that we can relate the log 16 base 2 plus log. We can switch that one to have constant base with what? The log 16 base 2. So we simplify. Let me copy. So plus, so firstly you can simplify that log 16 base 2 without wasting our time, much of our time, by saying what? So this one will be what? 16 will be what? In index form will be 2 raised to power what? 2 raised to power 4. Sure you get it. So plus, now this one we can switch it back to what? We can use the change of base law. Sure you get now, by finding the what? Constant base. So for you to solve this, by finding the constant base, you can make use of what? You can make use of 2. Sure you get it now. So to relate it with the log 2 raised to power 4 base 2. Or you can do it another way. I know mathematics, I don't need to. Or you can still use that reciprocal law. That is 1 over what? 1 over it will change what? 1 over log 4 base 2. Sure you get it now. Either of the two, you get the same answer. So let's continue. So we have log 2 raised to power 4 base 4 plus what? Plus log plus what? Log. So now using the expression, using the sixth law, change of base law, let me put it in parentheses. Sure you get it now. So that will be what? And I want to make this of 2 actually. That will be log. So that will be log 2 base 2 divided by what? Can use anything. Divided by what? Divided by but we can use 2 as the base. So because we've already have 2 as the number, so what can we do? So then you use reciprocal law, that is 1 over what? 1 over log, let me put it in bracket. That is what? So you switch the base. Sure you get it now. Log, so that will now be what? 2, that is log 4 base 2. We close the bracket. Now minus what? Space minus this expression here. So you copy, then I paste. Space. So you get it now. So let's solving this step by step. So automatically this one will be what? This one will be 4 log what? Log that is 4 log 2 base 2 plus what? So this one now, we can have the expression in form of what? By using index law now, that will be what? So that will be log that will be log what? That is and recall 4 is what? 2 raised to power 2. So that will be log 2 raised to power 2 base 2. You close it. Minus what? Minus this expression here. So this one too, we apply what? We apply change of base law. So following the same process, let me open the bracket. That will be what? So that will be yeah, that will be log. So once we put 1 over, so the number will switch. So that will be log 25 base 5. that will log close it. So we'll move to another line. Okay guys, now so that 4 log 2 base 2 will now be what? 4 plus what? Plus, so automatically this one too will be what? 1 over what? 2. So that is, this is how it's going to be. So that will be 2 log 2 base 2. So and this one now we can change this one to be what? To be what? We change it to indents. That is 5 raised to power 2. Are you getting it now? So we move to the next line. So 4 plus, so this one will now be what? It will be 1 over 2, because 1 over log 2, I mean 1 over 2 log 2 base 2 will be what? Because log 2 base 2 will be what? Will be 1. That is 2 times 1, which is what? Which is now what? 1 over 2 minus, so this one too will be what? Same expression. So we have what? So this one now will be what? Now be, so you take that, you take these two to the back of the what? To the back of that log. So that is why it will now be what? It will now be 1 over what? 2 log 5 base 5. So you get now. So then we move to another line. We have 4 plus, so 1 over 2, 1 over 2 minus, so automatically that one will be what? That one will be what? It will be 1 over 2 too. So we have 1 over 2. So here actually, so 4 plus 1 over 2 minus 1 over 2 will now be what? Will be 4. So that is the final answer for this expression here. So actually, from the example given in the slide that I'm using, is what? Is log 4 base 2. So if you follow the same process, you get the true answer. To actually, if you change this expression to 4 now, this will be what? The final answer will be what? Will be 2. So this is for this expression here. Evaluate log 16 base 2 plus log 2 base 4 minus log 525. So that is the answer. So can you see the solution? So this is how it's been done. So that is what we call what? Change of base law in logarithm law. So can take your time. So that is how to solve it. So that is what? That is change of base law. And you can see this one, evaluate log 4 base 2 plus, in which following the same process we have what? We have 2 plus what? And the final answer is what? Is 2. So it's 2. The one I use is 16. This one is what? Is 4. So the second example is what? It said log 5 base 3 multiplied by log 81 base 5 multiplied by log 125 base 27 multiplied by log 3 base 25. So how can you solve something like this? It's not that hard. So let me solve this example too, if time permit. So I will try to solve this one too. So if you are given this kind of expression, how can you solve it? Now you look through to the question. So if you have this kind of question, how can you solve it? So you look through what's is being given. So we have log 5 base 3 multiplied by log 81 base 5 multiplied by log 125 base 27 multiplied by log 3 base 25. You can see that what is common is 5 3 5 3. You see, from 81 27. So that means we can what? You see that we, but advisably we can work in order to relate everything with log 3 base 5. So how can we do that? So let's commence the solution. Let's start. So here we have what? So here we have log 5 base 3. So here now we can apply what? Once this one is different from this, we can apply reciprocal law. Shall you get it now? So using reciprocal law, definitely it will be what? Let me put bracket here. So that will be what? 1 over what? So this one will switch. Shall you get it now? So this one will now be what? So we can use reciprocal law and you can use the first one. So this expression will be what? Can switch from here. It will now be what? It can be, it will be, that will be log 5 divided by what? Divided by log 3, close the bracket, multiply by. So this one too, we can do the same thing in order for us to cancel out. So that will be what? Log, we have log 81. So that will be log 81 divided by what? Divided by log 5, close the bracket again. So give this space. So multiply by space, then you close this. Recall that this next line, it will now be what? It will be what? Log now be log 125 divided by what? Log 27. So we are using the law in logarithm, which is called what? Change of base. So we are applying change of base to this question given to us. So cancel out this, and the last one is what? So we have put it in bracket. So we have what? We have log, that is log 3, because log 3 base 25 will now be log 3. So what is the constant base we are now applying? Is 10. Shall you get it now? So that will be log that will be log 3 divided by log 25. Then you close it. So we move to the next line. So this one. So now multiply by this expression, log log 81 can be what? So that will be log 81 can be expressed as log 3 raised to what? That is 3 raised to power 4. So you get it now. 3 raised to power 4. Divided by what? Divided by log 5. Log 5. close it. So multiply by, so log 125, that is 5 raised to power what? 5 raised to power 3 divided by log 27 is what? That is log 3 raised to power 3 raised to power 3. Then you close it. So what else? So multiply by log that is log log 3 divided by, so log 25 is what? That is log 5 raised to power 2. Then we close it. So we simplify for that by saying that what? So you can, let me copy again. So we have log, so this one will now be what? That is 4 log that is 4 log 3 divided by log 5. Close it. So multiply by, so this one will be what? Will be to be log, that will be 3 log divided by 3 log 3. Close. So multiply by which is 5 divided by log 3 divided by 2 log 5. Close. So next line. So automatically, looking at this expression, 3 at the numerator, we cancel out 3 at the denominator here, and this one. So automatically this expression will be what? 4 multiplied by, now looking at this one is 5. So looking at this, we are left with what? 3 we cancel out 3, so we are left with log 5 base log 5 divided by log 3. So this is what I'm saying here. Sure you get it now. So here will now be 4 times. So and this place we have log 3 multiplied by, let me start again from here. We have bracket log 5 divided by log 3 multiplied by 4 log 3 divided by log 5 multiplied by 3 log 5 divided by 3 log 3 multiplied by 3 log 3 divided by 2 log 5. So I'm looking at the first one, log 5 divided by log 3 multiplied by 4 log 3 divided by log 5. That will be what? Automatically log 5 at the numerator, we cancel out the next log 5 at the denominator, and log 3 at the denominator of the first one, we cancel out the log 3 at the numerator. So that's why we're having 4 multiplied by. And the same thing goes to the third and the fourth expression, which is what? 3 log 5 divided by 3 log 3 multiplied by log 3 divided by 2 log 5. So looking at the log 5 in the third expression, we cancel out at the numerator, we cancel out the log 5 at the denominator. So we are left with, and automatically the third expression, which is 3 log 5, so 3 cancel 3, that leads us to log 5 divided by log 3. So that was why. Now, so and in the fourth expression, we have log 3 divided by 2 log 5. So, and the log 3 at the denominator, we cancel out with log 3 at the what? At the numerator. So that is why we are now having what? 1 divided by 2. So 1 divided by 2 will now be what? Will now be 2. That is our final answer. So that is our final answer. So you can check through. Let me just okay. So that is the solution for the second expression. So that is how to solve any question which involve changing of base. You either use the reciprocal or you find a constant base in order to change the log form. So this is example 2. This is example 3. You have to evaluate x, shows that we have log x base 4 minus log 4 base x equals 1 minus. So you can just see the solution here. You just do what? I use reciprocal law, which is changing of base law, and then you get now. So, and here I select log 4 base x equals to y. So using that, it leads us to quadratic equation. So after solving your question, then you substitute back with the expression and use a reciprocal law. So this is the solution here, and this is example 4. Example 4. See. So I'm trying to just solve many questions so that follow the step and you two will be able to tackle it. So the next law we'll be dealing with is what? Is changing of base. So is what? Is changing of base, and I will just explain this. You can apply changing of base, shows that this is the law here. So you use not changing of base. We've deal with changing of base in the sixth law. This kind of expression here is called what? Logarithm at the index. And whenever you have this expression, such that the base of the logarithm at the index means that the exponential or the power is equal to the base of that exponential. That means you are going to get the number. This is what you are trying to say here. When you have n raised to power log n base n, shows that the base of the index is equal to the base of the logarithm. So definitely you get the number of that expression. So logarithm at the index shows that the base of the index is equal to the base at logarithm. So whenever you have that kind of expression, for instance, something like this, I won't be able to show you the step here. So just follow this. I'm going to explain this. So you can see that you have to evaluate 5 raised to power minus 3 log 2 base 5 multiplied by 2 raised to power 2 log 3 base 2. So how can you do this? So the first thing is that what? You take that minus 3, which at the back of that log, using index law, you take it back to the what? To p the power of 2. So that was why you are having it here that is what? 5 raised to power log 2 raised to power minus 3 base 5 multiplied by the same thing to the second expression, which is what? 2 raised to power 2 log 3 base 2, which is now changed to what? 2 raised to power log 3 raised to power 2 base 2. Shall you get it now? So now, once the base of the logarithm is equal to the base of the exponential or the index, that means the expression will now be what? Will now be 2 raised to power 3. You see, that's very simple. And this one is having the base of the logarithm at the index is equal to the base of the base of the logarithm at the index is equal to the base of that index expression. So that was why that's one now that is the law. We change what 3 raised to power 2. So with this you can simplify from your knowledge of the mathematics. 2 raised to power minus 3 is also the same thing 1 over 2 raised to power 3 is equal to 1 over 8, and 3 raised to power 2 is what is 9. So that was why we are seeing at this expression to be 9 over 8. And the second example too, this one is even straightforward. 4 raised to power log 3 minus 2 base 4 equals 10. So once the base of the logarithm at the index is equal to the base of that index, that means with what? To be 3x minus 2 equals 10. So take that minus 2 or add plus 2 to both sides. So we have 3x equals 12. So yeah, this is a typo error. Supposed to be 3x, because if we add plus 2 to both sides, that will be 3x. So the final answer will be what? The final answer, so 3x plus equals 12 will now be what? Will now be x equals 4, because if you divide both sides by 3, you have what? We have 12 divided by 4. So, and I'll be 12 divided by 3, and 12 divided by 3 is what? Is 4. So the same thing goes to example 3 here. You can see. So, but before you solve this example 3, let me explain this. You can see that here is 9, but the base at the base for that logarithm is 3. So definitely that is telling you that what? You change the 9 to index. That will be 3 raised to inside bracket. You see the way I did it here. So that will be 3 raised to power 2 multiplied by what? 3 raised to power 2 inside parentheses multiplied by the power. That is minus 2 log 2 base 3. So we don't need to stress ourselves with the next expression multiplied by 2 raised to power 3 log 6 base 2. So because automatically, about before you simplify that, so after that expression here, then you can now multiply what? We can now multiply the base inside the parentheses with the base outside. That is why we have what? We have in the next line to be what? 3 raised to power minus 4, because 2 multiplied by minus 2 is what? Minus 4. That is why we have 3 raised to power minus 4 log 2 base 3 multiplied by 2 raised to power 3 log 6 base 2. So with that, once the base of the logarithm is equal to the base of the index, so definitely, but before applying that, you switch. So you can see that we switch. That is why we have 3 log 2 raised to power minus 4 base 3 multiplied by 2 log 6 raised to power 3 base 2. So eventually that will now be what? 2 raised to power minus 4 multiplied by 6 raised to power 3. So with that expression, and 2 raised to power 4 is what? 1 over 16 multiplied by 6 times c, that is 36 times c, that is 216. So if you cancel out, we have 27 over 2, which is what? 13 number 1 over 2. So that is the expression. That is, so we've covered, so I've worked on all the laws of logarithm. So we have the first law is what? Is index law. The second law is what? Equal number and equal base. This third law is unity. That is, whenever your log is being whenever you have log 1 base in any different kind of base, it will be automatically be equals to what? 0. And the next one is product law. The another one we cover is quotient law, followed by change of base, and followed by this one that I just talked about, which is what? Whenever you have logarithm at the index, shows that the base of the logarithm at the index is equal to the base of the index. So you know what to give you. So let me just so this is all we've been doing from the first class of the logarithm. So just check through and see these laws. So those are the laws. So first law, index law. Second law, equal number and base. Third law, unity law. Fourth law, that is product law. And the sixth law and the fifth law is what? Is quotient law, which is this one. So, and the next law is change of base. So That is what change of base law. So you can see it, how to change. That is the way you can change, and I work question on it, how to simplify. You can go through this. And the last one is what? Logarithm at the what? Logarithm at the index, so that you have this kind of expression, that is n raised to power log of m base n. So whenever the base of the logarithm is equal to, is the same thing as the base of the index, that means the expression will be equals to the number of that logarithm. So, and these are the solution. I've explained it. So these are the solution to the question given there. So if you have any challenge regarding logarithm, you can test me in my YouTube video. So watch, you can work out. That is my piece of advice to you. And then what? And don't forget to like and subscribe to my channel, because I'll be dropping more videos inside this channel, and we'll be gaining one or two things there. See you in the next class. Thank you.